All right, this problem 10.1.7h I want to do a little bit carefully so you can see the steps. So here's find the cosets of each subgroup in the specified larger group. So I'm trying to find the cosets of T in C star. Now C star means it's a multiplicative group because the star means that 0 is not contained. Now what is T? T is the unit circle. It's the set of complex numbers Z such that the norm of Z is equal to 1. Remember, the norm of Z is equal to the square root of the real part of Z squared plus the imaginary part of Z squared. So you should be thinking about, in the complex plane, the unit circle looks something like this with radius 1. So the real axis would be this way, and the imaginary axis would be this way. All right, now let's consider the cosets of T. These are sets of the form WT, where W is a complex number. Some examples would include W equals 1. In that case, WT equals T. So this coset is T itself. If W equals I, then IT is the set of numbers IZ, where the absolute value of Z is 1. So let's consider what this looks like. So suppose Z is an element of T. Then I can write Z in polar form as cis of theta. That means that IZ is I in polar form, which is cis of pi over 2, times cis of theta. Right? This is I in polar form. Now, if you remember, to multiply numbers in polar form, you simply add the arguments. So that's cis of theta plus pi over 2. Now, what does that mean? The absolute value of cis pi theta plus pi over 2, the R is 1. So that means the absolute value of this number is equal to 1. What does that tell us? This IZ is in IT. It's an arbitrary element of IT. But IT, all the elements in IT satisfy that the norm is equal, the absolute value is 1. So that means that IT is a subset of T. So since all elements have absolute value 1. Okay. So IT is a subset of T. But on the other hand, suppose I have a number Z in T. I can write that as I times minus IZ. If you use the associative law, the I and the minus I cancel. And the absolute value of minus IZ, well, minus I is cis of minus pi over 2. So minus IZ is cis of theta minus pi over 2, which still has absolute value 1. So that means that if I have Z in T, I can write it as I times a number whose absolute value is 1. So it follows that T is a subset of IT, since Z in T can be written as IW, where absolute value W is equal to 1. Okay. All right, so these two results show that IT is equal to T. This one shows IT is a subset of T. This one shows that T is a subset of IT. All right, so in fact, this coset IT is equal to T. Now let's see if we can generalize this argument. Let's take an arbitrary coset. So consider element of WT, where W is a complex number. Now in polar form, W in general will have a radius, so we can write W as R cis phi. R is the radius, phi is the argument of W. And let's take Z in T, which is the unit circle, and Z will still have this form cis of theta. So let's look at WZ. Well, WZ is going to be W, substitute W, and here's Z. Now again, when you multiply complex numbers in polar form, you multiply the radii and add the arguments. Now there's no radius here, so that's simply r, and then I have cis of the sum of the arguments. All right, now, so what is the absolute value of this complex number? Well, the absolute value is just the r part. Okay, so the absolute value of wz is equal to r. That means that wz is on the circle with center 0 and radius r. Okay, so you have center 0, radius r this time. And it's somewhere on here. I don't know where, but I do know it's somewhere on this circle with radius r. Now I could also write this as RT, because if I take anything on the unit circle multiplied by r, I'm going to get something on this circle with radius r. So here I've shown that wz, whenever z is in T, wz is always on the circle with center 0, radius r. On the other hand, suppose I pick any number on this circle, and I'm calling this v. Okay. Then I can write v as r cis alpha for some angle alpha. But then I can write v this way, as r cis v, cis minus v, cis alpha. Right? The cis v and the cis minus v cancel out. Now why did I do that? Because the r cis v is going to give me w. This is my w part. And what I have left over, cis alpha minus v, is a complex number, and the complex number, which I'm calling z prime here, has absolute value equal to 1. So what do I have here? Here I have any number on this circle of radius r can be expressed as w times a number that's in T. So any number on this circle radius r is in wt. So what have I shown? I've shown that wt is contained in this circle of radius r, and furthermore, I've shown that this circle of radius r is contained in wt. So that means that every left coset of t in C star is a circle in the complex plane with center 0. All right, so that's how that works out.